Hello students of 12th class. I am Pardeep Koul, lecturer in chemistry, and I am standing before you today with the unit that is our sixth unit, where we are isolating these elements and then we are doing extraction of some metals. We have already done extraction of aluminum and then we have done extraction of iron. Today we will be extracting one more metal which is very important metal in our day-to-day life, that is copper. Now before going to extraction of copper, let me make you feel that certain steps we have already done. For example, we have done smelting in a blast furnace. However, that step will be taken care of this time also, but I will not go into details of that step because we have already gone through that detail. So now coming to today's topic, that is extraction of copper. Now there are ores of carbon, copper. We must know some ores of this copper. For example, we have an ore of copper known as copper glass, and its chemical formula is Cu2s. Then we have another ore known as cuprite, commonly known as ruby copper, and its chemical formula is Cu2O. It is an oxide ore of copper, while as the first one was sulfide ore of copper. Then we have another sulfide ore of copper and very important ore of copper, that is copper pyrites. This is the most important ore of copper known as copper pyrites, having chemical formula CuFeS2. Then moving to one more ore, that is malachite. Malachite having chemical formula CuOH whole thrice, that is carbon hydroxide, and in combination with copper carbonate and copper hydroxide, these together make one more ore of copper, that is malachite. So these are some ores of copper. Now while going for extraction, most of the times we extract copper from this ore, that is the sulfide ore. Most important ore of this copper is sulfide ore, that is copper pyrites, CuFeS2. So today we shall be extracting copper from copper pyrites. Now moving to the extraction steps. Moving to extraction of copper from copper pyrites, that is main ore of copper, having molecular formula CuFeS2. If you look at the chemical formula of this ore, what we find? We find that in addition to sulfur is one of the impurity present in this ore. In addition to sulfur, we have iron also, but this iron is not the metal to be extracted. This iron is this time an impurity that too needs to be removed, and only then we can extract copper from copper pyrites. So moving to steps now. The first step, you know, is the common step for the extraction of all metals, that is crushing. If you remember how crushing is done, we take the ore, for example here copper pyrites ore, we take that ore, we crush it into a fine powder by using jaw crushers. Jaw crushers are very large in size. We put the ore in these jaw crushers. These jaws crush the ore and change it into powdered form, and as a result we get powdered ore. So this is all about step number one. In step number one, what we do, we take the ore, here in this example copper pyrites, we crush it in big and large these jaw crushers, and as a result finely divided powdered ore is obtained. So this is step number 1. Then moving to step number 2, the common step, concentration. And if you remember, there were various methods of concentration, and only one of those methods are to be taken, and that depends upon what? Which method to be taken for concentration? That depends upon the nature of metal and the impurities. Whenever you are taking sulfide ore, for example, here we have taken the sulfide ore of copper. Whenever this sulfide ore is taken for extraction, always remember that the method of concentration that we use is known as, or that method can be, froth flotation process. This is a method of concentration, froth flotation process or froth flotation method. Now what is done in this method? In this method, a suitable solvent is taken. For example, this is a solvent, a suitable solvent. By suitable I mean that your metal should get dissolved into it. So when powdered ore is put in this suitable solvent, powdered ore, what happens to this powdered ore? The impurities, that is sulfur, which is present in it as impurity, that forms the froth, that forms the lather here at the top of this solvent, froth. That is why the process is known as froth flotation. Froth floats here, and the metal that goes into the container. So this froth can be removed, and once we remove the froth, sulfur gets removed, though not completely, though not fully, but up to some extent sulfur gets removed from the powdered ore. Now this remaining part, that is taken for further extraction. So this is all about concentration of this crushed ore. So once again I will tell you that as far as concentration of this copper pyrites is concerned, this is done by a method known as froth flotation method. In this method what we do, we dissolve this powdered ore in a suitable solvent where sulfur forms the froth, and froth is removed, and as a result the rest of the material is taken for further stepping. Now after concentration we move to next step, that is roasting. Roasting, if you remember, roasting is a process of heating in excess of air. When we heat the concentrated ore in excess of air, so that other impurities get oxidized, because since this in this process we are roasting it, that is we are heating it in excess of air. What is the function of air here? Air will oxidize the impurities. So when roasting is done in a container known as reverberatory furnace. Reverberatory furnace. In this furnace, very strong heat is provided to the concentrated ore. And what happens during roasting? During roasting, this ore, that is copper pyrite, CuFeS2, this is the copper pyrite ore. It on oxidation, that is it combines with oxidation and undergoes roasting. This is roasting, heating in excess of air. So it gets changed into copper sulfide, iron sulfide, and sulfur dioxide. Sulfur dioxide being gas evaporates out, and these two, they are further subjected to roasting. For example, let me go to the roasting of this one first, that is Cu2S. By roasting I mean reaction with oxygen. This is again roasting. Now what will happen? It will get roasted to copper, Cu, 4Cu plus sulfur dioxide. Sulfur dioxide is a gas, it will go out. Then after this sulfide, that is copper sulfide, we will go to the iron sulfide. We will do its roasting like this, FeS plus O2. It will form iron and sulfur dioxide. this gas goes out. So iron is obtained as impurity, copper is the metal that we require, and these two reactions are because of the first reaction. So this is all about roasting. Now as a result, when roasting is completed, we get an ore known as roasted ore. Roasted ore. Now after roasting, we move to another step that is known as smelting. Smelting is the fourth step. Smelting, if you remember, smelting, it is basically reduction. The roasted ore is reduced with carbon. And if you remember, in case of iron, we had done smelting in a big container known as blast furnace, and we shall be using that furnace again. Now I shall not go into the detailed construction of that furnace, blast furnace. What we do in blast furnace, we take ore. Which ore? The roasted ore taken that was obtained in the last step, that ore. Then coke, coke means carbon, plus sand, that is silica. These three are taken together, and they together are this mixture, the mixture of ore, coke and sand. This is known as charge. This charge is put in blast furnace, and then strong hot air is passed through the furnace, and during that process certain reactions take place. What reactions are those? Like this. If there is any iron sulfide present in the ore, it gets oxidized to form ferrous oxide, and this being gas, it goes out of the outlet of the furnace. This is a gas. So we get iron oxide. Now this iron oxide is further subjected to the smelting in the same container. That is, it will undergo again oxidation. Rather, it will combine with sand, since sand has been mixed here. Sand, SiO2, this is sand. And as a result, we will get silica. We will get iron silicate. This is silica. This is, now this FeO, it is flux. This is flux rather. Flux means which helps in removing impurities. And this is flux, and this is impurity. And when they combine together, they form slag. And this slag is removed from the bottom of this blast furnace. As far as copper is concerned, now your copper that gets melted at a very high temperature in the blast furnace, because there is a high temperature in blast furnace. That copper melts down and goes to the bottom of the furnace and can be collected from the outlet. So as a result, we get copper in molten form. So this copper still is not 100% pure. So it is purified by the last step in the extraction, that is refining. The last step is refining. And how refining is done? Suppose we again do electro refining. What we do in electro refining? In electro refining, we dip two electrodes, one of pure copper that we obtained in last step, impure copper rather. We have got copper, but that is not 100% pure. Impure copper, that impure copper is made anode, that is, it is connected to positive terminal of the battery. This is positive terminal. Then this is pure copper. It is made cathode, that is negative electrode, since it is connected to negative terminal of the battery. Now these electrodes are dipped in a solution. That solution be of the same metal. That if the metal is copper, it should be a solution of copper, say copper chloride or copper sulfate. Now This is copper sulfate. Now we will carry on electrolysis by connecting the battery. Once battery is connected, what happens? Pure metal from the impure metal goes into the solution, and same amount of copper that goes and deposits at cathode, and this process continues till whole of the pure metal from this impure copper first goes into the solution and then deposits at the cathode. So we can collect pure copper at cathode, so this rod gets thicker, while as this rod gets thinner, because whole of the pure copper has first gone to the solution and then later it has shifted to the cathode. So that is all for today. This was all about the extraction of carbon. In the next unit we shall be taking extraction of zinc next time. Till then, bye. Thank you very much.